So now let's look at an application problem involving this idea of function composition. For example, it says the cost to buy tickets online for a dance show is $60 per ticket. So part A asks us to write a function that represents the cost, C of X, in dollars for X tickets to the show. So C of X, C of X is going to be equal to cost per ticket times number of tickets. Right? But on part B, there is a sales tax of 5.5% in decimal form. That is actually 0.055, right? There's a sales tax and a processing fee of $8, flat fee, for a whole group of tickets. Write a function that represents the total cost, T of A, for A dollars spent on tickets. All right? Let's first of all say, if we know that we're going to spend A dollars on tickets, well, they're going to charge you the ticket amount, A dollars, and then they are going to charge 5.5%, so 0.055, and that is times the total dollars spent. And so what that comes out to be is when you combine 1A plus 0.055A, you get 1.055A. Okay? Now all this is the cost of the tickets, the total cost of the tickets, just with tax applied. So the total cost, T of A, is going to be the 1.055A, all right, and then plus the $8 processing fee. So that is the function that represents the total cost for A dollars spent on tickets. Now on part C, when they ask us to find T composition C of X, recall that means the outer function T evaluated at the inner function C of X. All right? So for us, it's going to be T evaluated at, the inner function is 60x. Get that from right up here. And so when we evaluate this T function right here at 60x, this is going to look like 1.055 times the 60x, and then don't forget about the plus 8. So I think we can now clean this up a little bit and multiply the 1.055 times 60, and this comes out to be 63.3x plus 8. Now, what that function is going to represent is that is going to represent the total cost, including taxes, including the processing fee, for X number of tickets. All right? Whereas this function above was just, hey, here's what the cost is going to be if you know you spend $8. All right? $8, not $8, $8. On part D, it says to find T composition C evaluated at 6. T composition C, remember, is this 63.3x plus 8. They wanted us to evaluate T composition C at 6. And so that's going to be 63.3 times 6 plus 8. Let's see, 63.3 times 6 is $379. And this will actually be an 80 cents. Once we add the processing fee to that, 6 people can go to the show for $387.80. All right, so the meaning and the context of the problem is that is the total cost, including taxes and fees, to purchase 6 tickets. Okay, so we can have composition of 2 functions, which that is basically mixing one function into another function to create a new function. We can also reverse the process and break apart the mixture of 2 functions, if you will, okay? So, for example, if h of x is defined to be f evaluated at g of x, okay? Remember that the outer function is the f function and the inner function is the g function. And so they want us to find 2 functions, f and g, such that it comes out to be what h of x is here, which is the 4th root of 9x minus 5. And so one way to do this is to say for the inner function, that's going to be the stuff underneath the radical. I'm going to say I'm going to let my g of x be the very most inner stuff that's happening to x, the 9x minus 5. Now, if that is the case, then what's the other operation left to do to that? That's just going to be to take the 4th root of that. Okay? So that is how you decompose or break apart a mixture of 2 functions. All right? Now next, it says the graphs of f and g are shown. We want to, given the graphs of f and g, all right, the pink and the blue one, we are wanting to, let's see, M is the blue. We are wanting to get each of these. First of all, on part A, M plus P of 1 means to find M evaluated at 1 and add that to P evaluated at 1. Okay? So, M evaluated at 1 is, that function value is 4. We're going to add that to P evaluated at 1. That means this point right here at 1, 2. P evaluated at 1 is 2. And so our answer for M plus P evaluated at 1 is going to be 6. All right. I've got a lot going on here. On part B, we're going to do P evaluated at -4. And from that, we are going to subtract M evaluated at -4. All right, P evaluated at -4. When x is -4, our P function is up there at +4 minus M evaluated at -4 is right here. M evaluated at -4 is -2. And so our answer is 4 plus 2. This one also comes out to be 6. Crazy. All right, on part C, okay, we're going to have M divided by P evaluated at 3, which is M evaluated at 3 divided by P evaluated at 3. All right, let's see what each of those values are. M evaluated at 3 is 2. P evaluated at 3 is, 0. And so M divided by P evaluated at 3 is undefined. Okay? Let's see if we'll have enough room. I don't know. D says M times P evaluated at 3. Okay, remember our first step is to write that as M evaluated at 3 times P evaluated at 3. All right, on this one, M evaluated at 3 is still 2. Now, when we multiply that by 0, 2 times 0 is just going to give us 0. Okay, that's part D. Now we're going to get into some compositions here on E, F, and G. Okay, all right, M, composition P, evaluated at 0. Remember, the way to rewrite that is it is M, the outer function, evaluated at the inner function P at 0. And again, it's a matter of working from the inside out. So the first thing I'm going to do is come over here and figure out what is P evaluated at 0. That is this point right here at 2. Now, what M evaluated at 2 says to do is it says go to your M function, and when x is equal to 2, now you're up there at 3. Okay, so see the different pieces we do this in. M evaluated at 2 was this point right up here at 3. Okay, I'm going to clean up my graph a little bit because I'm getting too many points on there. All right, let's do F now. F says P composition M evaluated at 0. Now the outer function is the P function, and we're going to evaluate it at M at 0. All right, once again, work from the inside out. So inside there, the M evaluated at 0 is that point right there, 4. Now, P evaluated at 4 is how we read that. And the pink function evaluated at 4 right here is, look at that. Open circle, so it's not defined there. So this thing is undefined. All right, on G. This one already wrote it for us, yay. So we're going to have the outer function is the P function. And first of all, we need to find what is M evaluated at -4. M evaluated at -4 is -2. So now this is telling us, go to your pink function, the P function, and what is our function value when the x is a -2 on our pink function? Right up here, our answer is going to be 4. Okay? Okay, so let's finish this on out. The function f plus g is defined by f plus g of x, and that means to find f of x plus g of x. The function f divided by g is defined by f divided by g of x, and it means f of x divided by g of x, as long as that denominator g of x is not equal to 0. Number 3, let h represent a positive real number given a function defined by y equals f of x. What is that difference quotient? Okay? Remember that the difference quotient is f evaluated at x plus h minus f of x, all divided by h. Number 4, the composition of f and g denoted by f composition g is defined by f composition g evaluated at x means, or is equal to, the outer function, the f function, evaluated at the inner function, g of x.